Alright, in this video I'm going to be talking about authentication protocols and go kind of deep into EAP, which stands for Extensible Authentication Protocol. And what EAP is, it is a framework detailing how other protocols that implement EAP should be developed, and there's many variants of EAP. That's why it's a framework. It's an underlying system. So one of EAP's purpose is to provide a way to securely transport keying material. So this would be like username and passwords, things like that. It supports authentication methods like Kerberos, token cards, certificates, smart cards. EAP also provides a way of authenticating information over untrusted airwaves and is used for wireless point-to-point connections. So when you connect to an access point, EAP is usually used always in wireless transmission. However, you can use it over land, and that's an acronym called EAPL, or EAP over land. It provides a method for authentication to a central server, so credentials do not have to be stored locally at every access point to a network. So normally you would have something like a radius server, and you would put your username and password whenever you would try to connect to a Wi-Fi network, and then those credentials are passed to that radius server. Now, the first type of EAP extension is LEAP. It stands for Lightweight Extensible Authentication Protocol. It was developed by and is Cisco proprietary version of EAP, and it was made before the 802.1x standard was approved. And it utilizes dynamic web keys and mutual authentication, which would allow clients to re-authenticate continuously or continually. A shortfall to LEAP was that it uses a modified version of MS-CHAP, which is the authentication protocol that did not use a strong method to protect the user's credentials. An attack tool called ASLEAP or ASLEAP was released in 2004 that could exploit the ultimately weak protection. LEAP should be avoided when possible, but if LEAP is used, a complex password is strongly recommended. It also requires the use of a username and password. So let's have a demonstration on this. I have a wireless controller, which is controlling access points, and I will show you how, from a client side, how to authenticate via LEAP here. So here you see the wireless network, and when you are using LEAP, you have to choose the EAP method and then put in your username and credentials. So right now I have a username of Bob, and the password is also Bob. And once you put it in, go ahead and connect, and then you should be able to connect to that local network. Now, if I go to my wireless controller, I can click on this link called Clients and see that someone connected to this certain AP using that profile name, which is, there's the wireless SSID. Click on it, you get to see Bob logged in, and the type of authentication we did is LEAP. You get to see there, EAP type. Okay. So that was LEAP. Now we have something called PEAP, which stands for Protected Extensible Authentication Protocol. Was created by RSA, Microsoft, and Cisco, so they teamed together. And this addresses confidential issues with EAP. So EAP itself does not provide encryption, so variants like this can provide the confidentiality that's needed to protect our wireless connections. PEAP encapsulates EAP messages over a tunnel that is secured by TLS, which is Transport Layer Security. It requires the use of a server-side digital certificate, which creates the tunnel, and then the client will pass its credentials through the TLS tunnel. So like before, let's go ahead and see what it looks like when you are the client. So here you could see the SSID of local PEAP. I choose the EAP method of PEAP. And then there you see the options for the certificates. They kind of stay there. And then you just go ahead and put in your username and password. We are still going to be logging in with Bob. And then we should connect. And then once we connect and our credentials are passed on, then we have successfully connected using PEAP. Now if I go back to my wireless controller again, click on clients, you can see that we logged into the SSID of local PEEP, and we are using the authentication type PEEP. Okay. Now we have EAP TLS. Again, TLS stands for Transport Layer Security. Mutually authenticates clients to servers via the use of certificates and utilizes TLS to create a secure connection. Similar to Leap's method, but does not use passwords, but an RSA handshake is used between the user and the server. So again, with Leap, they both sides authenticate each other, but that was just with a username and password. Now, EAP TLS uses both sides will use a certificate. The advantage of using EAP TLS is that it can be configured for two-factor authentication. Disadvantage of using EAP TLS is that it can be more complex to deploy because of the various components. Every time you try to incorporate a certificate authority, things get more complex. However, the more complex the configuration, the more secure your network is going to be. Now we have something called EAP TTLS. It extends the concept of that whole TLS tunnel and works similar to PEEP. EAP TTLS utilizes that TLS to form a tunnel between the server and client. Client passes on credentials within the tunnel. This differs from PEEP. However, it differs from PEEP in that EAP TTLS can support non-EAP methods like PPP authentication, PAP, and CHAP. The thing about this whole EAP TTLS is that since it's similar to PEEP, only the server certificate needs to be configured. The client does not need a certificate. Now we have EAP Fast, which stands for Flexible Authentication via Secure Tunneling. Was developed by Cisco to support customers that require strong policy enforcement but do not want to deploy digital certificates. EAP Fast provides protection against a variety of network attacks, including man-in-the-middle, replay, and dictionary. Has two phases. The very first phase is the phase 1. Establishes a mutually authenticated secure tunnel through the use of a PAC, or Protected Access Credential. Phase 2 performs the client authentication in the secure tunnel, and then client will then send the username and password. Now, if we configure our SSIDs for EAP Fast, then this is what it'll look like on the client side. So go ahead, find that SSID, choose the EAP method, and the EAP method is going to be fast. Then you put in your username and passwords just like normal. And if everything is successful, you will connect to that network. And it worked. And again, from my wireless controller, we could actually verify that. Go back to clients. You get to see that we logged in via that local fast SSID. You click on it, you get to see again Bob logged in. There's his IP address, there's his MAC address. Scroll down, and we logged in via EAP Fast. All right. Then we have 802.1x. 802.1x is the framework. Again, framework structure of an underlying system, which defines 3 roles in the authentication process. So there's 3 key players to 802.1x. We have the supplicant, authenticator, and authentication server. The supplicant, which is the endpoint, which is the client that is requesting access to the network, and this could be something as a PC, a printer, an IP phone, many different types of supplicants. Even a user could be a supplicant rather than the device itself. Then we have the authenticator, where the supplicant first talks to the authenticator, which is the device between the supplicant and the authentication server that will facilitate the authentication. So it is the device standing guard of the network. If I want to get access to the network, supplicant has to talk to the authenticator. Then when the supplicant passes on his credentials, to the authenticator. Authenticator is then going to forward that to the authentication server, and the authentication server is the entity that validates the identity of the supplicant and notifies the authenticator to allow or deny the request of the client. This would be something like a Radius server. So this is kind of what's going on here. You got the supplicant, which is the user, whether it be the actual person or the device itself. It's going to send its credentials to the authenticator. Most of the time this would be the switch. Switch is going to forward those credentials over to the Radius server, and everything, basically it's going to use Radius. It's going to encapsulate the EAP credentials, or I'm sorry, the EAP method is going to be inside of a Radius packet. So in this example, users are authenticating to a Radius server via whatever EAP method we specify, while their machines are verified at the switch by EAP over LAN. No network access is granted. All right. So this has to happen first before we get anything, even something such as a DHCP IP address. Okay. Once the credentials are successful and the authentication server gives the go-ahead to the authenticator, then the authenticator will open up the port, and then the PC will get its IP address. Last but not least, we have this thing called Radius Federation. It is similar to a transitive trust model, but passes on credentials through Radius with the confidentiality of EAP with another Radius server. So let's say we have this PDA here, or a smartphone or whatever, and it's trying to connect to an application. And that application first wants to pass on those credentials to its Radius server. And of course, this Radius server, since it's a remote network or whatever, it doesn't have the credentials that this guy is trying to log in with. If he is federated with another Radius server, he will forward on those requests, and where that username and password is stored, it'll give it the go ahead and be like, yeah, that's good to go. And then now that wireless client will have access to it. So again, it is like a transitive trust model. I send it over to him. Those credentials aren't on this particular Radius server, so I'll forward that on to another Radius server which I trust. Those credentials are there. Give it the go ahead, and then it is good to go. So I hope this was informative for you, and I'd like to thank you for viewing.